Content of your screen. Kena. Kena punya. Saya punya ni. Jadi kalau kita okay. Okay. Punya operator.
Hello. अभी ठीक है
Lamik lang to.
Kita apa nama pun? Full screen.
Oh, ada kita ni. Kita kembali kita. Kalau ada kita slide ni juga. Kita tu ada ni.
Betul. Ya.
Sini
Or click here to return to the video or when I will stop the video.
Apa yang kita perlu?
Mungkin play ini, play ini tak?
Oh, kenapa tak?
Turn off the remote. Okay, nice ini.
अच्छा
Okay, ni. Kalau yang ini tu, ada remote.
ठीक है सर हो गया
So ni,
Wow. Apa window?
ni,
Window ni.
ni.
Okay. Okay.
आदि देखो लेट्स स्टार्ट
Okay.
Am I audible? Deepak?
Ini banyak apa ni?
Yes.
Okay.
Huh?
Share that screen between that.
Yeah, you are audible. Yeah.
This record video forward.
Should we start now? Others will be joining.
Start. You should start.
Yeah, kindly mute yourself. Everyone should mute yourself. Only the speaker should unmute. Yeah. May I hand over the mic to our Secretary General? I am Deepak Parotia on behalf of Indian Federation of United Nations Association. I welcome all of you, and I hand over the mic to our Secretary General, Mr. Suresh Srivastava, to welcome all the guests.
Thank you, Deepak. It's my great pleasure and honor to have such an eminent personality to attend our webinar of the Indian Federation of United Nations Association. And I, on behalf of Indian Federation of United Nations Association, welcome you all wholeheartedly. Dr. Sanjay Anil Shah, the Deputy Director, IMD Guwahati. Dr. A.C. Lingdong, National Center Seismology Science. And I would like to also tell Dr. Lingdong that Dr. Mukul Sangma, who is the former Chief Minister of the Meghalaya, was still recently our chairman of our organization and remained for a quite long time our chairman. So, Dr. Lingdong, you are most welcome. Professor Divesh Walia, Department of Environment Science, Northeastern University, Shillong. Dr. Santosh Kumar, former Director, National Institute of Disaster Management, New Delhi. and Dr. Purnima Chauhan, former Secretary General of the Himachal Pradesh, or former Culture Secretary of the Himachal Pradesh government. And of course, we are lucky to have Dr. Professor Ashan Reddy with us from Arunachal Pradesh, who is also the president of the Arunachal Pradesh UN Association, and also a very active member of IFUNA and member of the IFUNA. So, most welcome, Dr. Ashan Reddy from Arunachal Pradesh. And of course, we have with us Mr. Parvatiyar, who is our media advisor as well as the program director. So, he is most welcome. So, I welcome you all on behalf of the Indian Federation of UN Association. I need not to repeat the topic because the topic is very relevant these days. Need for disaster prevention in the wake of growing seismic activities in India. We know it that till recently there were so many earthquakes in India, so many typhoons, so many things. I mean, we personally feel that we have been playing with the nature too much, and that has resulted in too much earthquake, typhoons, tsunamis, wildfire, and more dangerous, the melting of the glaciers. So these all things are happening, and perhaps it is because we have been playing with the nature. And perhaps by playing with the nature, today we are facing this pandemic, this COVID-19 pandemic. I would not like to go into the controversy that how it started and how it is not started. But since we are also very close to the UN China and other UN associations also, so there, I would like to go briefly without blaming anyone that what transpired about this. There is a very young professor in Wuhan Virology Institute. He was Li Wengliang, a very young professor. He found it out that this virus is a very dangerous virus. We do not know whether this virus is man-made or nature-made. We do not know. Still, it is a mystery. Though the Australia has joined the bandwagon of demanding an inquiry, thorough inquiry about this origin of this virus. But we would not like to go into that controversy. But what is important that if at all we have played with the nature, that the result are catastrophic. This we are seeing right now in our own lifetime, that the whole world is infected by this pandemic, and we do not know how long it will continue and how we will be able to save the humanity from this catastrophic disaster. So at the same time, when we talk about the disaster, then the question arises: suppose if because we are playing with the nature, if disaster takes place, how we should save ourselves? That's a part of our education, and we are very lucky that we have many experts on this to speak on this subject. So I again welcome you all I sincerely hope that this webinar will give us an insight that how to manage ourselves during the time of disaster, and also educate us about this catastrophic playing of the nature by the human being. Thank you very much. So I hand over to my mic to Mr. Deepak, who will be the who will be running this program. So, Mr. Deepak, please take it on. Thank you very much.
Thank you, Mr. Srivastava. And I once again thank all my guests. And let me start with a brief introduction of the United Nations Association. Actually, UNAs are the extended arms of the United Nations. And we are more into people-to-people diplomacy, as well as we reach out to the people to aware them about the UN agendas and programs. And we also have a special consultative status with the ECOSOC of the United Nations. And whatever deliberations we are going to have here, we will be presenting them at different forums. And we will also publish them in our news magazine, People and UN. And before I start, today being the World Literacy Day, we thought it very appropriate to select this subject, mainly because over the last few months, we have witnessed a number of mild earthquakes everywhere. particularly in Northeast, and more particularly in Mizoram also. And many papers have also come out recently on what the potential of these earthquakes could be. And that's why we thought that this is a perfect day to uh, discuss about uh, literacy, literacy, and that is disaster prevention literacy. And with such an eminent panel with us, I don't want to take much time. First, I would like to invite Dr. Sanjay Anil Shaw. He is the Deputy Director General uh, of India Meteorological Department, Guwahati. And he would be, I request him to speak something on monitoring earthquake for creating seismic resilient society. Uh, we know that we cannot predict earthquake. So how do you monitor, and as scientists, how do you work on it? Can you please throw light on that? Yeah, Dr. Sanjay Shaw.
Yeah, please just wait. Can you see my screen?
Yes, we can see.
Okay, okay. Now, basically, of course, the topic is very relevant. The need for disaster prevention literacy in the wake of growing seismic activities in India. The most important thing is that we should know about the earthquake and literate let people know about earthquake, because what is happening that when earthquake occurs, most of the people don't know what to do. So what happens that once a earthquake comes, immediately people become panic and they are not sure what to do. And due to this particular reason, lots of casualties in terms of life as well as property occur. And so this is a very important thing. Uh, First of all, I would like to go through a few slides, and then I would like to say something more about here. Okay, so this is a very common thing and nothing new about this thing about the seismology, how this term came. And of course, as far as this earthquake is concerned, we all know that it is a sudden release of a strain energy which is accumulated in the rocks. And the outermost crust of the earth, which is what we call the lithospheric plates. So they continue their slow motions, and stresses build up in the crust, especially near the plate boundaries. And due to these stresses, when this stress is built up, the crust and in the crust until the stress exceeds the strength of the rock or the friction along a pre-existing fault, and then after that a sudden slippage of rock along a fault occurs, and the ground shakes, and this seismic waves travel outwards from the portion of the fault that broke. And this is just like expanding ripples from a pebble drop in a still water. When we drop a pebble in a still water, we can see how these uh, ripples expand from center to outside. Similar is the case of these seismic waves. So, what happens when earthquake occurs? So, earthquakes occur due to forces of geological origin along weak plains like faults. It is quite natural, quite obvious that where there will be any weak place, such places are more vulnerable for earthquakes. So in Indian region, earthquake occurring near plate boundaries such as Himalaya are known as interplate earthquakes. Apart from earthquakes from the Himalayan belt, there have been earthquakes of relatively lesser magnitude and lesser magnitude frequency in the peninsular India. And we know why it is so happening. So such earthquakes are known as interplate earthquakes and are attributed to the stresses building up in this area on account of compressive forces arising out of northeastward movement of Indian plate. So this is the main hypothesis, this continental drift, and according to this hypothesis, uh, that Earth's continents were originally joined together as a single landmass, which is called Pangea, which split into pieces and drifted to form the present-day configuration of continents. What we see now. In early years, it was supposed that it was like this, and after that, every yeah, these land masses staggered, and then many new continents came up. So this plate tectonics, the uppermost rigid layer of Earth consisting of crust and a part of upper mantle material extending to a depth of about 50 to 150 kilometers, and there are now about a dozen or so irregularly shaped pieces, what we call them major plates, and these are in constant relative motion with a velocity of about 2 to 10 centimeters per year. And as far as Indian subcontinent is concerned, this it has been found that Indian plate, it is moving with at an average speed of 5 centimeters per year. So plate tectonic theory is a theory. This explains a number of relative factors, including relative motion of these plates and the resulting deformation of earthquakes along the plate boundaries and adjacent regions. So after that, what we saw that this is the major plate tectonic thing, and here in especially in Indian region, we can see that how these this Indian plate is moving. So now this is the yeah. Now, what is actually the behind this thing? So, from the concept of plate tectonics, the Indian plate is moving in a north-northeast direction and colliding with Eurasian plate along the Himalayan mountain range. Here we can, in this figure, we can see that how this Indian plate is moving in a north-northeast direction, and it is colliding with Eurasian plate. And as per the plate tectonics, northeast region of India is the easternmost projection of Indian plate, where the plate is thrusting underneath the Eurasian plate, creating a subduction zone and the Himalayas. So this can be explained with this particular figure. In this figure, we can see that as in what is this subduction zone. It is the region of the Earth's crust where tectonic plates meet. And tectonic plates are massive pieces of Earth's crust that interact with each other. The places where these plates meet are plate boundaries. So in northeastern region, this falls under seismic zone 5, making it prone to earthquakes because many earthquakes come in this region. Like for example, in Assam itself in 1897 and 1950, the two massive earthquakes were recorded, 8.7 and 8.5 on the Richter scale, and these are the seismic zones of India, and this has been the data has been supplied by IMD, and according to Bureau of Indian Standards, these four zones have been identified: zone 2, 3, 4, and 5. And as far as this Indian region is concerned, India is concerned, and as far the area here just I want to show this thing, that zone 2, the blue color is zone 2, yellow color is zone 3, green color is zone 4, and red color is pink color is zone 5. So it means that zone 2 is the low intensity zone, zone 3 is moderate intensity zone, zone 4 is severe intensity zone, and zone 5 is very severe intensity zone. And as far as the area of Indian subcontinent is concerned, about 43% of Indian region comes under zone 2, and 27% of land of India comes under moderate intensity zone, and 18% of land of India comes under severe intensity zone, and 12%, that is the entire northeastern India, parts of Jammu and Kashmir, Himachal Pradesh, Uttarakhand, run of Kutch in Gujarat, and parts of North Bihar and Andaman and Nicobar Islands. Altogether, it is about 12%, which comes under Zone 5, which is very severe intensity zone. So, basically, now earlier this actually India Meteorological Department was looking after all these things, but now after the formation of Ministry of Earth Sciences, this new National Center for Seismology has come up, and it has a good number of observatories. It is there are about 115 seismological observatories, and these all seismological observatories are telemetric, and they are working 24 into 7. And with the help of all these observatories, we are getting very accurate the location of the origin of the earthquake. So basically, the data collected from all these network stations is compiled, processed, analyzed, and archived systematically at National Seismological Database Center at IMD headquarters, New Delhi. The earthquake data information and seismicity reports are supplied to various user agencies like insurance companies, industries, uh, river valley projects, and various scientific, academic, and R&D institutions in India and abroad for research purposes. So seismological data and earthquake related information is also supplied to various agencies dealing with relief and rehabilitation measures, earthquake disaster mitigation and management related matters, seismic zoning, etc. And analog charts are being digitized for long-term preservation of seismic along chart data in electronic form for use by research community. Basically, now I want to add some views that this now it is very important to create a seismic resilient society, because what I told earlier, that people are still not very much aware about when earthquake comes, how to react, what to do. So most important thing is to understand the first of all, it is to understand the earthquake source process. So for that we have to monitor the earthquake. So for that, all over the world, many seismic observatories are there. And as I told that in India itself, we have about this uh, NCS has 115 telemetry uh, stations where this earthquake monitoring is done. So this is very important, and uh, and we should know that as far as India is concerned, about 59% of Indian land is vulnerable to be affected by earthquake. So important thing is that first of all, there are three things. So one is before earthquake. What should be done before the earthquake? Before the earthquake means people should know that in which place they are residing. That is in which seismic zone the person is residing, and according to that. According to Indian Bureau of Standards and other various agencies, advisories are there how to build the building according depending upon the zone, earthquake zone. So people who the person who is residing in a particular zone, he should know about the place where he is residing, and according to if he wants to build the house and any construction is done, any major planning is done, maybe river dam or maybe industry, whatever maybe. So the construction should be in terms of that. This is a before that, and if before the if earthquake is what preparations should be done, and how to keep one emergency kit for us. There are many things in this. And during and second part comes during the earthquake. So when earthquake comes, how to react? So many uh, educational institutes, children, even in offices, even in institutions, all are being given, some mock drills are done, even this NDRF and NDMA, many agencies are giving, they are demonstrating all these things, that mock drills are being done, that during earthquake how to react, what to do. So these are all these things, and of course, and after the earthquake, it definitely it becomes what will be the how to take a relief, and different things are there. But as far as we are concerned, scientific community, as scientific community we are concerned, we are more concerned with about this earthquake observation, and the analysis of data, and how to this do more and more R&D. Like for example, in case of general weather forecasting, now IMD is very much doing in a very good weather forecast is being done, that like for example, now casting is done, what will happen in after half an hour or 1 hour or 2 hour, and like a short range forecast, what will be the weather system uh, in coming 24 hours, in coming 48 hours, in coming 72 hours. Then comes medium range forecast, that is from say about from day 3 to day 10. This is a medium range forecast, and even extended range forecast is there, like what will happen, what will be the outlook of weather in coming 15 days, or 20 or 25 or 30 days. And of course, at last it comes the long range forecast, like this is what we all know about the monsoon prediction. But as far as this earthquake is concerned, this what we what we call the lead time is very very less, very very short. So this earthquake early warning system, this is being developed, and people are working on it all over the world. And as far as the present scenario is concerned, people are just uh, we are able to know that this the moment the earthquake comes, so what is the location, what is the time, what is the magnitude, all these things are there, and immediately what as far as like for example, this the earthquake starts, and immediately warning message after an earthquake occurs, that can be disseminated. But still it takes a short time that the ripples go. But during this time, what is the thing, that the lead time is very very less. So as far as science is concerned, nowadays at present we are not able to. The whole world is still not able to predict the earthquake, the time of occurrence, the place. But definitely in near future, being a scientist, we cannot say that it is impossible. Definitely a day will come when this earthquake prediction with proper lead time will come. So this is what I want to say, and of course, my friend Dr. AC Lindo is here, who is the director of Central Seismological Observatory, Shillong. He will give more light on this particular topic. Thank you.
Thank you, Dr. Sanjay Shaw. What I suggest that any questions if you have, we can ask after the presentation of all the speakers. And as you said about the telemetric observatory, and we have Dr. Lingdo here. It will be very interesting to know what qualitative changes such laboratories have brought into the prediction of earthquake. So, Dr. Lingdo, could you please throw some light on this in your speech? That would be of great importance to all of us.
Okay, I'll just display my presentation here now.
Sure. You can use it.
Is it visible now?
Yeah, you can share the screen from present now. You go to the present now, and from there you can share your screen.
Yeah.
There is on your screen you can see one tab that is called present now. From there you can present your screen.
From the Disha.
Yeah.
Can you open the tunnel?
Bottom on
Give
the
me, yeah.
bottom on the screen.
You just click on present now, then you can present your entire screen. Yeah, that is there.
Is it visible now?
Yes, it is visible.
Okay. Okay, so I'm going to talk a little bit about earthquake monitoring and earthquake information dissemination. Good afternoon once again. I'm Dr. E.C. Lingo, Director in charge of Central Seismological Observatory, National Center for Seismology, Shillong. So the topic of my presentation is earthquake monitoring and earthquake information and dissemination. This will be just a brief introductory presentation. So if you go to the first slide, I think most of these things have been explained by Dr. Shaw, so I'll just skip this slide. Okay, earthquake risks and vulnerability in India. As we all know, the entire Himalayan region is considered to be vulnerable to earthquakes of magnitude 8 and above. So during the last 50 years, we have seen such earthquakes as the Shillong earthquake in 1897. The revised magnitude is 8.1. Kangra now in Himachal, that is 8.0. Bihar-Nepal border in 1934, 8.3. And Assam-Tibet border in magnitude 8.6. So now scientific publications have warned, few scientific publications have warned that very severe earthquakes are likely to occur anytime in the Himalayan region, which could adversely affect the lives of several million people in India. So now coming to the next slide, I think Dr. Shaw has covered most of this, so I'll skip this slide. So this is the seismicity in and around India. Now you can see there are three ellipses that we have drawn. The first one is in the Himalayan region. You can see most of the earthquakes are concentrated there. Himalayan region extending up to the northeastern region. So this is due to the continental collision in the north, and in the east, that means most of the northeastern region, we're experiencing earthquake because of the subduction activity and the intra-plate activity in peninsula in domain. You can see very sparse earthquake activity there in the central Indian region. So now this is tectonic map of northeastern India. We'll just talk a little bit about this. And the word tectonic comes from the word Greek word which means build, to build or to the process of building. So in this case, the process of building is the stress that is being accumulated along the faults. I think Dr. Shaw also has talked about the faults and everything, structures. So these are the faults. If you look at the left-hand side of your screen, these are the faults, some of the main faults distributed all over the northeastern region. So because of these faults, now if you look at the right-hand side of your screen, you can see those green and black dots. Those are the earthquakes occurring in the northeastern region since 2000. Because if we go beyond that, the screen will be very crowded. So we have just selected earthquakes since 2000 up to July this year. So most of the earthquakes you can see they are occurring along those lines, those fault lines. That means indicating that these faults are still very active. And you can see on the right hand side of most of the earthquakes are concentrated on the Indo-Myanmar border. So we'll switch on to the next slide. And this is the seismicity of northeastern region in the last 10 years. You can see the magnitudes of 3.5 to 4.5. The total number of earthquakes are 862. And of course, as the magnitude increases, the frequency magnitude increases, the frequency decreases. Now magnitude 6.5 to 5.5, we see there are 155 earthquakes. And if you see the magnitude 6.6 to 6.9, there are only 3 earthquakes in the range of 6.6 to 6.9 magnitude in the last 10 years in northeastern region. And this is the yearly earthquakes in northeastern region. And you can see there in 2020, so far, as per this graph, we can see there are only 99. Actually, now it has crossed more than 100. So there's a likely probability that it'll exceed the year 2016, which are 126, and 2012, 127, because we are getting so many earthquakes this time, especially in the Myanmar-Mizoram border region. So this is seismicity again since 2011 to up to July this year. Now, if you see those red dots there, those are the red triangles. Those are the seismological observatories that NCS is having. There are 20 observatories there. So because of these seismic observatories, we get a good data, earthquake data collection from this region. Now coming to the next slide, this is again the seismicity of northeastern region. Because since March 2020, northeastern region has experienced seismic activity of minor to moderate earthquakes, less than 6. Some earthquakes like the magnitude 5.9 on 16 April 2020 occurred near Indian border, which was also felt in many parts of northeastern region. These earthquakes were felt locally in all the northeastern states, because most of these earthquakes, if you see in Mizoram area, those are the earthquakes that contributing to the major activity in the northeastern region. So I'll talk a little bit about the National Center for Seismology, the things that it's doing. So services provided by NCS. If you see there, we have the earthquake monitoring. This is 24/7. We have an operational center there in Delhi and here in Shillong. So we record these earthquakes from the 115 observatories scattered all over India. And when we record these earthquakes, we analyze the data. And from there, the dissemination part comes, dissemination of earthquake information. We disseminate the data through website, SMS, smartphone apps. And we also do this earthquake micro-zonation studies. This is for establishing those building codes that we have now in place. And micro-zonation studies we have done for Sikkim city and Guwahati city and Delhi. And we also undertake this MEQ. MEQ stands for micro earthquake studies and field surveys, earthquake aftershock activities, and data supply. We also supply data, earthquake supply for insurance claims, extra for research students, extra. So earthquake monitoring, we have here 115 stations as of now, which are equipped with broadband and strong motion recorders with real-time VSAT communication connectivity. So the operational network capability can detect any earthquakes of magnitude 3 from 3 and above. So these are the plans that we have for the next year. Monitoring in future, we are planning to upgrade to 300 new stations. And this is the real-time earthquake monitoring in 24/7 basis. So as we all know that warning for future earthquakes is not possible as of now, but timely dissemination of earthquake information plays a very important role in dealing with the post-disaster relief and rehabilitation. And National Center for Seismology maintains around-the-clock monitoring of seismic activity in and around the country. So after getting the data, we analyze and we disseminate the information to all state concerned and central government agency responsible for carrying out relief and rehabilitation measures, and also to the press. This is a schematic diagram of seismological operations. So if we see from the left-hand side, we have these stations. So from these stations, field stations, we collect the data. It goes through several processes. And if you see there, those yellow PCs there, RTSMN, OSN, DTN, and NEN, those stands for Real-Time Seismic Monitoring Network, Operational Seismology Network, Delhi Telemetry Network, and NEN stands for Northeastern telemetry network. So from these 4 networks, we collect the data. And the most important part is on the extreme right side, earthquake information dissemination system. Once we have analyzed the data, it goes to our website for the public and through SMS, and we have smartphone app also. We'll come to that later. Then fax, Twitter, Facebook, and email. So this is how we disseminate the data to the state government agencies, the press, and to the general public. And this is a little bit about the history of response time status during the years. So, several years ago, we had only analog observations, and to analyze the data and to disseminate the data, it took around 1 hour. But when we entered into the digital age, the dissemination of data reduces to 30 minutes. And with the digital observation, VSAT and auto location with good softwares and increase in the density of seismological stations. So the information we can pass on to the public is 10 minutes. And now, with the increase of more stations, we have reduced the information time to from 5 to 8 minutes. So within 5 to 8 minutes, you'll be getting the earthquake data. And this is how the earthquake report, how we release the information. There are 2 levels actually. Level 1 takes 2 to 5 minutes, and the recipients are basically Ministry of Earth Science officials, National Center of Seismology officials. Then the mode of dissemination is SMS, website, a mobile app. Then after thorough scrutiny, we go to the level 2. This takes another 5 to 15 minutes because more data is coming to the stations and more accurate analysis is there. So the recipients are Ministry of Home Affairs, Central State Government, News, Media, Public. So, and the mode of dissemination, we have increased the media through SMS, email, fax, website, Facebook, Twitter, mobile app, extra. And this is our website. You can, if you're interested, you can go through this www.seismo.gov.in. So it's a very interactive website and very informative. So it'll be very useful. If you feel any earthquake, you can take part there in that DYI, do you feel it section. So you can give your inputs there. And we also have, this is our website. If you open our website, you can see the list of earthquakes, current earthquakes happening, and also the past earthquakes all over the world. And this is our mobile app. It is, you can download this app in Google Play Store or Apple App Store. And the features of this app, this is RISEQ, Real-Time Information System for Earthquakes. We have overlaid earthquake information on multiple layers such as seismic zoning map, intensity map, do you feel it, TYFI map, tectonic map, extra. Selection of data with UTC or IST settings, it depends on where you are, epicentral distance from the cities, etc. So this is a very useful app. So I would request you to download this app, IRSEQ. And this is a seismic hazard microzonation map of New Delhi. So this is in the scale of 1 to 10,000. And this is basically earthquake hazard map. If you can see those legends there, the red part is the most hazardous area. So these maps are very useful. This serves as good input for the builders, construction companies, engineers, and the town planners. And earthquakes in NCT Delhi during 2001 to 2020. So not so much as we have seen in northeastern India, but there are quite a few, good number of earthquakes. Total earthquakes 127. Earthquakes with magnitude 2 and above 107. And they have had an earthquake of 4.6 also. That was on the 26/11/2007. And this is the Delhi telemetry network, seismic telemetry network. Now we have a total number of stations, 19 stations, and we have these Delhi temporary stations. So there are 9 stations. So these record the earthquake activity in around Delhi region. And the future plans for NCS, we want to upgrade our network upgradation. You want to upgrade a network, upgradation of dissemination system. We want to upgrade our dissemination system so that it will be much more useful to the public. And studies to delineate subsurface structures over Delhi region to examine association of earthquake activity with specific structure. And of course, Dr. Shaw has talked a little bit about earthquake early warning systems. So we are also planning for earthquake early warning systems in the future. So thank you very much.
Thank you, Dr. Lingdo. I had just one question. You talked about the response time, 5 to 8 minutes response time. What do you mean by this? What does it mean actually? Is it also in terms of extent of damage it has wrought?
No. This is the response time in terms of disseminating the data to the public. So that means earlier we had to download the data, take out the data from these analog instruments. So we have to take out the charts, print them, analyze, take out the scale, and do all the mathematical calculations manually. So by the time we calculate the magnitude manually, it will take 1 hour to pass the data to the public. So, but now due to the accurate softwares that we're having, everything automated. So everything the softwares will do, and the scientists will just have to analyze and check. So the main thing is to pass the information, to disseminate the information as quickly as possible to the disaster managers and the public. So now we have achieved a time of 5 to 8 minutes compared to what we have done earlier. It took around 1 hour. Yes. So we are trying to improve this response. I mean the response status of how quickly we should disseminate the data to the public and to the government. So as of now,
I have a question. That is very interesting that this response mechanism has improved. I'm Purnima Chauhan. I'm from Himachal.
Okay.
And being in the category 5,
yes,
we know what a risk that we always, whenever there's a tremor, we think it's a repeat of Kangra.
Yes.
So this response time improvement is actually disseminating the information to the affected people. Are you using any form of artificial intelligence to be able to, disseminate this automatically? Human error is not accounted for then in that case?
No, as of now, we are still using those systems that are disseminating the systems through those email, through our website, fax, Twitter, Facebook, and SMS, and through those systems only as of now.
Yeah.
So maybe in the near future we can go to AI this thing also. So I don't know.
Yes. Second question is that you mentioned micro-zonation, which is excellent for many purposes.
Yes.
For building, you have said, for land use. But as far as, the moment you get this warning and you want to pass on the warning, so you already have the micro-zonation, so you know where this threat is most potent. So is there a mechanism that it goes down to the lowest level immediately so that preventive action is taken and loss of life and property is minimized?
Okay, let me correct you, madam. There, actually, the response it's not for the warning. Actually, the response is to minimize the time of which an earthquake has occurred, the time of which we have to disseminate it to the public.
Yes.
So we are trying to minimize the time of occurrence of earthquake and the time from which we deliver the message to the government and to the public.
Yeah. So the wider, you had two channels in that. So
Yes,
I'm saying that instead of having, time is slightly wasted in that channel as well. So if it is a flat structure where the warning goes exactly to the places which are most affected, more and more people will be able to save themselves.
Actually, here we are talking in terms of disseminating the data information when an earthquake has occurred. Suppose an earthquake has occurred 5 minutes back. So this is just to relay the information to them.
So it is not in advance.
No, this is not an earthquake early warning system. That is in the list of our future plans.
Okay.
Actually, Dr. Lingdo, I had a first-hand experience of Gujarat earthquake of 2001. I was very much present there. And what I could see that for being in the media, I wanted to get information. I could not get any information the first day. And I saw a Delhi media telecasting all wrong information because there was nothing. I was sitting in a building and they were saying that building was demolished because of this. And it was only after 2 days or maybe after, the next day when the ham operator teams came from Hyderabad and they went to Kutch, that we could get some idea, semblance of idea what is happening. We talked to the chief minister. He was sitting at the police control room, and even he was not knowing. So how far have we progressed from that stage? That was 2001. Today is 2020.
You see, at that time, the disaster management process also has not taken up shape as it has done compared to the year 2020. So now we are having these disaster management mock drills. We're having these incident response systems. And tomorrow also we'll be having this tabletop exercise for the government of Meghalaya, organized by the NDMA. Last month we had a similar exercise, tabletop exercise, organized by NDMA with the state government of Mizoram. So this is in lieu of to prepare the people in the wake of this seismic activity occurring in the Indo-Myanmar border and Mizoram region. So now, as you have seen throughout the years, our detecting capabilities also has improved. And what we are talking just now also about the dissemination system also, this has improved quite a lot. I think in 2001, we can disseminate the data maybe within 1 or 2 hours. So because most of the time, at that time we use a dial-up connection. We have to dial up the data using those GPRS method, which are outdated now. So we have to dial up the data, collect the data, analyze from all 20 stations or whatever stations we have that time there. So it takes time. So, but now everything is automated. So, and it comes to 5 to 8 minutes, the dissemination time. And at that time, the disaster preparedness, we don't know at that time how it has been dealt, how it has been done. And most of the people, they are not quite prepared as of today, because we used to have these regular mock drills and preparedness. So maybe these factors play an important role.
Thank you, Dr. Lindo. Thank you, for your excellent presentation. And now I invite Professor Devesh Walia, Department of Environmental Science, Northeastern Hill University. Actually, Dr. Walia, recently there was a report, actually some research study published that revealed that Arunachal Himalaya is generating moderate earthquakes at 2 different depths. So what does it really mean, and what your studies are, and how grave this concern is?
Yeah, thank you for this. Actually, there have been a lot of reports, lot of earthquakes in the present time. So we need to understand a bit in a more systematic manner, so that we understand. Although there have been many earthquakes in the past also, but during the COVID time, because we are there in the peace, so definitely we need to take care of any such activity, and we become more afraid of any such activity. So I'll take you through some of the important things which are related to India, that these earthquakes are not new. So just I'll take you through this. Practically, we all know by now that these are the natural processes, that building up of the stresses and all such things, they are the natural processes. And as the population grows, the people living in a less riskier area, they try to live in a more riskier areas too. And so we cannot stop these processes. So we can stop them by scientific study, by educating the population, and by following the engineering practices, and definitely the disaster management plans and all such other things. We know that these are nothing new, like whatever we talk of seismicity or cyclone or whatever, they are not new, they have been occurring. So what happens that these disasters are becoming more few because of the increasing population, or more frequent because of the increasing population, and the people living in disaster prone areas, now they are shifting towards more disastrous areas. So now the risk is increasing. So this is what is the time to act. Now it is there, because we all know that these are the natural processes, as I told you. So they create hazards, But what happens that these hazards, they keep coming, keep going, and they may be, say, if the landslide occurs in a forested area, so it doesn't have that much impact. But if the same landslide occurs, along the road or along the area where some school or some activity is there, it creates, gets converted into the disaster. So that's what the important thing is, that those natural processes will go on, but so that they don't become the disaster, we need to understand. And all such activities, we know that to be a disaster, there should be hazard, like there should be earthquake, then there should be local conditions such that this earthquake is able to destabilize all those areas. Then there should be some vulnerable areas, highly vulnerable areas, and there should be low resilience, because during the time of the build-up for the earthquake, we get time to reduce the resilience, to take care of the vulnerability, or to take care of the site conditions. If we are not prepared, finally we get trapped, and the same hazard gets converted into the disaster. With reference to the India, especially with reference to the seismicity, especially, we know that in the past around 70 million years, especially, the Indian plate has moved from the southern hemisphere to the northern hemisphere, and now it is colliding with the Eurasian plate. This is what is a very common photograph, so to say. So what happens that as the plate moves northward, so the large plate of Eurasia, which was resting on the North Pole, because further it cannot go as such because of the rotation of Earth and all. So this Indian plate, when it get collided with the Eurasian plate, this plate is a very heavy and stable plate, Eurasian plate. So finally it has going down, and when the continental part started colliding with the Eurasian plate, which has given rise to big mountain chain like Himalayas and such. And you can see that because the convex nature of the Indian plate, or the border of the Indian, or the border of the Himalayas, indicates that which side from the northern side it is going further north, or say from south of the Eurasian plate it is going towards the north, and it is colliding. So this convex portion indicates how the collision is. But the important thing is that we need to understand the active tectonics and the seismicity, because it may pose threat for the survival and sustainable development of our civilization. So that's what it is, very, very important, and we need to understand the lithosphere dynamics so that we are able to understand the complete system and the impending seismicity, if any. So now, as I told you, that in the past 70 million years ago, from that time onwards to the present time, the Indian plate has moved from the southern hemisphere to the northern hemisphere, and in the process it has accumulated, it has compressed almost 1,500 kilometers, and this 1,500 kilometers is just compressed, and that's what it has given rise to Himalayas and all, so many things in the region, and the region becomes very, very active. And that's what is the crustal shortening of around 1,500 kilometers, which is not small. And it has this shortening, how the shortening is accommodated. So whether the region is still tectonically active and all, we need to understand. So basically, just to tell you whatever in the figures earlier was, that since Eocene time in particular, or we call it around 55 million years ago, this collision of the Indian plate with the Eurasian plate started with the formation of the Himalayan arc. And once this convergence went on, then after the north-south convergence was to certain limit, after that this Indian plate started moving anti-clockwise, and there was a collision towards the eastern side also with the Myanmar plate, which started, it took around 5 million years for the Indian plate to close completely, and then it started collision with the Myanmar plate around that time. But these collisions of the northern boundary of India or the Indian plate, or the northeastern part of the Indian plate, makes the whole region, especially the northeastern region, one of the highest rates in the world because of the seismicity. And every year at least one earthquake of 6.5 magnitude occurs. But the earthquakes, as I told you, that because of the collision of the plates, they may occur, and once one plate goes down, Then as it rupts, this is what is also known as the Benioff zone, or this is the zone where earthquakes may occur. Now what happens that these earthquakes slowly should be deeper, because when this part goes down, it should be deeper. But in the past few years, it is seen that there have been, in the past 20 years, it has seen that there have been earthquakes whose the focus is very, very shallow. You can see that there was Kunlun earthquake in 2001. The focus was around 17 kilometers. There were earthquakes in Sikkim and Nepal. The focus were around 19.7 and 8.2 kilometers. In Yushu, around 14 kilometers, and Wengchuan, around 8 kilometers. These are very shallow focus earthquakes. Now, these shallow focus earthquakes are more disastrous because the energy, the moment the earthquakes are generated, their energy is there, and when they reach to the surface, they have got the potential to destabilize. So for this, there were some studies just to understand that why these shallow focus earthquakes are there. So in those studies, they have carried out using magnetotelluric or electromagnetic induction of the earth. So for that, carrying out these red lines, wherever they have carried out the work, they have seen that near the surface of the earth, there is a crustal flow. Crustal flow means the liquid molten material is there, which is moving because of the compression of the Indian plate in the north-south direction. Then all these material, because of the compression on the surface, first top 30 kilometers there was a compression, but this compression impact is there beneath also, and due to which the crustal flow is taking place along this zone. So this crustal flow is going along the further north or further east of the Indian plate. So that's what it makes the things very, very interesting to know, or very, very important for us to understand that because of this crustal flow, what may be the impact on the seismicity in the northeastern part, which is one of the already most seismic prone areas of the world. And you can see that there have been different layers, and these deep channel flow, which even reaches up to the upper crust or the upper mantle. These are the flow which are demarcated by different studies, which pose the risk. At the same time, when we see the GPS is the present day study, as such we can call it in a simple terms, because if the present day, by whatever rate the earth is moving, we can know. So if we put some permanent stations, we can find out how they are moving. So you can see that all over the Indian plate is moving towards the northeast direction. They are moving towards the northeast direction, but as this is the part of the Eurasian plate, or this is Tibet. So what happens as further, if you just put the stations, you see that it starts absorbing this pressure. So the pressure is still building up in this zone. At the same time, they start these arrows, they start rotating, and you can see that the whole of the crust is moving in the eastward, or whatever, towards the south direction. That's what
I don't know whether I just interrupted your slide. Only one slide which is coming. You are showing slides, but probably just the title slide is coming.
Okay. That may be because of now. Which slide you can see?
Now it's fine. Now it's a circle. Why do earthquake occur?
Oh, yeah. So it means you have missed all the slides, earlier slides. Can you see now earlier slides?
No, we did not see. Yeah, we could not see.
We have missed all the slides.
We missed all the
right now.
Right now, only the latest one that you have shown.
Yes, we missed almost all slides.
It's only your picture.
Okay, it's okay, no problem.
Oh, is it? You could have told me, because I just stopped. Now I don't know what you can see. You are seeing now.
No, that's fine. That's fine. Now we can see it. Yeah.
But are the slides moving?
No, they are not moving.
I was going back.
No, there is no. It's not moving.
Not
moving. Oh, just wait 1 second. I'll just close 1 second and then again share again, because those slides are not for me to talk. They are for everyone to see. To me, though, now can you see, or it is taking time to load? I don't know. Normally, it doesn't happen.
No, we can't. You have to share it actually. Yeah.
No, it is shared only.
Now we can see. Yeah. Now we can. Yeah, we can see all the
The
slides.
slides are moving also.
Yeah, they are moving.
Yes.
Okay, let me make it big. Maybe now it stops. Okay. Is it? You can see now. Hello.
Yes, we can see.
Oh, all these slides we have passed through. We have passed through all these slides. So, what should I do? I'll come to that slide. At least from that onwards, you will know.
Yeah, that's okay. That's okay.
Yeah, all these things I was showing the deeper crystal structure and all those. This is what is the GPS system which I wanted to show. Yeah, we have come to this. So now you can see slides now moving.
No, it's still it has got stuck. It has got stuck at plate tectonics.
First, that was the first slide.
Yeah,
So
that's only you have seen.
yeah, we are seeing. Now it has
Start moving.
It means when I make a full screen, it is not. Is it now you can see the slides?
Yes, now
we can see. And it's moving also.
Achha. So better not to have full slideshow.
Yeah.
The moment slideshow is there, there must be some issue. Because this is...
could be, yeah.
Or should I try slideshow? I don't
Yes,
know.
sir. Yes, sir. Yes, sir.
Try once again slideshow so that...
Yeah, no issue.
Is it moving now?
No, again it's got stuck.
Here only.
Yeah.
It means right now now you can see. It's
Now I
okay. So I'll not make the slideshow. I'll start here. Is it okay now? Slides change?
Yes, changing now.
Yeah. So now basically we all know that earthquakes occurs because I showed you actually this is with reference to this. The GPS says that you can see the length. Actually, I'll go now. We cannot in the slideshow mode. Show mode, I cannot go back because here you can see the length. So length means the crust is moving with that much space. The crust is moving. All right, say 20 centimeter per year. Now here it goes down to 5 centimeter per year. So whole plate should move with the same pace. So we can find out the areas where the stresses are getting generated. So now once we can locate the places where stresses are getting generated, that's what the stress. Say if I'm compressing and this part is moving and this part is not moving, it means this is the zone where the stresses are getting generated, getting stored. And once they starts getting stored and once they go beyond the critical limit, then only the earthquakes come. And then only those are the places which are also known as the tectonic plate boundaries. All right. So now just with reference to Indian terrain, because the Indian plate once collided, so it has given rise to different faults, main northern thrust, then main central crystalline thrust, the boundary thrust, or the different thrust. Thrust means when one plate is there and the other plate goes beneath it, so that's what it is thrusting down. So if they break, then if it is a normal process is there, then it is a normal fault or something. So thrust is actually low angle reverse fault. Just to tell that if they compress, then because this side faces compression, but just perpendicular to it, it gets extension. So both the areas are the places where the earthquakes may be generated. So the earthquakes generated in Delhi, in those zone, Rohtak and all, they are due to the extension zone. Compression is there. If I compress, then the area gets extended. Like those areas are there, they are because of areas. As we know that all along the Himalayan terrain, there have been major earthquakes, and on the basis of this, one can find out where is the seismic depth and where are the chances of major earthquakes being originated. There have been lot many earthquakes in the northeastern area. I'll just go faster. So what happens that these earthquakes, they have been occurring. So the Indian region is is very, very hazard prone. And if there are bigger faults are there, it means, in other words, the longer duration, say if the magnitude 8 magnitude earthquake occurs, say some in the Sumatran region and all, so it could break around 1,500 kilometers area, and wherein around 10 feet area has gone down. So you can understand that 1,500 kilometer area, and it is going down by 10 feet is a huge amount of energy. So that much amount of energy is supposed to be stored, and for breaking 1,500 kilometers, definitely it will take longer time. So that's why if the earthquake is for longer time, it means it is of longer magnitude also. So if the earthquake occurs and the time period you are feeling, by that also you can understand whether it is going to be disastrous or not. So that's what is important. On the basis of occurrence of the earthquake, on the basis of intensity of the earthquake, the UNDP and other different organizations, they have made such maps through which you can get some help, so that you can know that what are the high risk zone or otherwise. So so normally the earthquakes, they occur, by now you might have understood that if the compression is here, so it will have some structures parallel to the zone of compression, some structures perpendicular to the zone of compression. So the earthquakes, they have got specific orientations. So if we carry out studies systematically with reference to those orientations, we'll be able to find out the probable impending seismicity. Second important thing is that wherever these earthquakes they occur, you can see that there have been zones, some thrust or some fault zone. There only the earthquakes occur. If there is less fault zones here, you can understand that the less activity or the less seismicity is there. Whereas more seismicity occurs in the zones wherever faulting or the thrusting takes place. You can, just to tell you that with the help of active tectonics, we can find out, because if one plate is going down because of the load of the one plate, the other plate, it gets locked. It won't be able to move. So until unless this pressure is override, this pressure of the subducting plate or the plate going down, it is able to balance the force or the pressure of the overlying plate. So that's what by different instruments, by GPS or by different instruments, such studies are possible. And one of the studies using the magnetotelluric electromagnetic induction of the earth, we too have carried out, and wherein you can see we have carried out from Bhutan or say Daranga to Doki, and then there were some repeat experiments also, wherein you can see that from north to south, this part. So you can see that the Bengal sediments penetrating beneath, means the Indian plate going beneath, and as it is going beneath, it is uplifting the Shillong plateau, and like this you can see. And once the plate is going beneath, those are the zones where the earthquakes are originated, more earthquakes. And there are some of the earthquakes, they are at little bit deeper also. So there are some different tectonics, they play the role. That's why the earthquakes, they occur at different depths. But the more disastrous earthquakes, they are of the shallower depth. But in 1897, there was one major earthquake in which is known as the Shillong earthquake, although that time Shillong was in Assam. So that earthquake was able to demonstrate to the people or to the seismologists that these earthquakes have potential to crack whole of the crust. That's what they have got, the potential to crack the whole of the crust. Crust means a thick, more than 30 kilometers thick lithospheric area, and that's what is very, very important for us to understand. And at the same time, there have been many GPS studies being carried out. Even we are also carrying out the GPS studies. These are some of the stations placed, and we can see that on a smaller scale. See, once we have carried out the deeper crystal structure using magnetotelluric, then we have placed our GPS stations. Then we can find out, say here it is movement is this much, here the movement is not there. It means it indicates in between, if both the parts are moving with so much speed, there must be some fault in between. Here the plate is moving with this rate. Don't think too much, but only just to see that it is moving at this rate. Here it is moving at this rate. So it means there has to be some place where the stress will get generated. This is from in between from, this is Aizawl, this is Guwahati. So in between Guwahati to Aizawl also, there are so many zones where the compression is taking place, and that's what is written here also, that the compression is very, very prominently, or it is very well, it can be studied. So with reference to the Indian region, as the plates are colliding, so we can understand that these collision tectonics is very, very prominently taking place, and it is still active. We should not think that the tectonism has died out. It is still active, and it is need to be studied in greater detail, so that we can know the impending seismicity, and we can create some resilience. But as I told you, that we need to tackle the issue related to seismicity from all round systems. So we need to we know scientifically that what are the zones where the stresses are built up. We also should know that how to reduce the risk. So the one important thing which was discussed in the earlier presentation also by Dr. A.C. Lingdo, that dissemination of warning is very, very important. And as rightly pointed out by the moderator, that in the Gujarat earthquake, they were not disseminated. That time we had mobile technology was not up to that level. But slowly, still today also, if the earthquake comes, the signal or the warning may be around 30 to 2 minutes, 30 seconds to 2 minutes before the earthquake. So we need to be technically trained, so that we are able to pick up those emergency signals, and we are able to save our life. Because of the earthquakes, we know that they are the high energy events, or the chances of their occurrence are low, but the damage, the impact is very, very high. So we need to take care. Now, once if we know that if the earthquake comes, then it may break the connectivity. So because of that connectivity, there should be emergency kits at all the villages, so that those peoples, they may be there. We need to identify and plan of action for the risk groups, so that those people, they should know that what type of first aid be given to what kind of person. That's what is very, very important. And there should be trained forces at all levels. There should be emergency material and all. So I wanted to go further, but I'll not go further into the deeper part. But we all should know that are we ready for an earthquake is very, very important aspect. Because as we go to Japan or some places outside, there should be what one should do in the case of earthquake at that specific place. If the person is passing through whatever area, whether he is entering the bus, if the earthquake is there, what he should do. If he is entering a train, what he should do. So like this, wherever earthquake occurs, there should be some handbook or something written, so that the people, they don't get panic. It is seen that the more say if the hazard occurs, earthquake comes and goes, but if the people, they become panic, then they may become affected due to the earthquake, or due to the seismicity in that region. So we need to be very specific. One important slide, the last slide, I want to show that actually what happens, that when the earthquake occurs, people are in the panic. After 1 week, they just fear about the earthquakes. After some times, they may start blaming the builders, they may start blaming the officials and all such people. And after from 1 month to 1 year, they become less receptive. And from 1 year to 10 years, they start diminishing in their interest. They think it will come once in 10 years or 100 years. Why should we bother? And slowly, after 10 years again, they become very, very reluctant to take place unless the earthquake comes. But just remember that the phase after the earthquake, the phase is to build up. If we properly build up, probably the next earthquake, if it comes also, it may not be that much disastrous. But the most important thing is there, that we should know, in the case of earthquake, one should not panic, one should not try to run out. Just a simple thing is that drop, cover and hold is very, very important for you to carry out. Whatever work we have carried out, I would like to thank Ministry of Earth Sciences, because we have carried out so many things. We have demarcated the zones, and with this, I would like to thank you all for patient hearing. I'm sorry that my slides didn't work properly, but it's okay.
That was fine, Dr. Walia. Thank you very much. I had a question. Yeah, of course, you all have said that it cannot be predicted, but are there any prior indicators?
I'll tell you. I didn't say, excuse me, I didn't say that it cannot be predicted. Very important. We are working on the prediction only, and we are monitoring 4 important parameters. Earthquakes are like any other event, natural event. Only thing is we need to know, like whether in the beginning, whether predictions were there and they were not coming true. It doesn't mean that we stop predicting the weather conditions. Similarly, in Taiwan, in Japan, China, all these countries are in process of prediction. Only America failed, so they have stopped predicting the earthquake. They have failed. But other countries, they are successful or failures are there. So the research is going on. Similarly, in India, even government of India, they have established at 4 places the multi-parametric geophysical observatories. They call it MPGO at 4 places. One in Uttarakhand, which is called Guttu. Another one is at Shillong, which is maintained by, the first one is maintained by Wadia Institute of Himalayan Geology. Second one is by at Shillong at Indian Institute of Geomagnetism. Third one is at Tejpur, which is maintained by NIST, Jorat. And the fourth one is at Imphal, which is maintained by Manipur University. So they are recording around 21 parameters. The target was around 4 or 5 years back to have a first model. So we are still expecting. We are also doing from our university side. I showed some of the acknowledgements. Through their projects, we are working, and we are also trying to build a model so that in the beginning, model may not be true, but at least it doesn't mean that we should stop predicting. So the possibility of earthquake prediction is definitely there, but the prediction is little heavy term. We can use the term forecasting. Later on, prediction will come. People started with prediction to be popular, but prediction is the wrong term. We should start with forecasting. Forecast is a long duration. Like I said that the Indian plate is colliding, so that's what is first forecast. Time and magnitude, I don't know, but the area is at least known. Like this, slowly we should move on.
Thank you for this. I wish to draw your attention to one point, that before the major earthquake of Kutch, there were a series of mild earthquakes in Saurashtra region for about a couple of years. I remember that. And this time also we are seeing a number of these tremors. So are they precursor to something major? Of course, some institutes have said that no, there is nothing, like Delhi also. And second thing, you talked about the crust. In Delhi this time, I noticed that the depth was quite low when the earthquake occurred. So how serious is the concern?
Yeah, the first thing, you said that some of the organizations, they said that nothing to worry about the minor earthquakes. It is not. It is a bad thing because those people without properly studying should not say that these earthquakes are not precursor. So they may be precursor, and we again will be caught unprepared if such thing happens. So the first thing is these minor seismic events or the smaller seismic events, they may lead to major seismicity. So whether they are leading to major seismicity or not, without studying them properly, it is not good to comment. I know that the government of India, the international, any governments, they don't have much seismic seismometers installed in Mizoram. In Mizoram, in the past few days, not many earthquakes there are around 21 earthquakes from 18th June. From 18th June till today, there are around 21 earthquakes. Around 5 earthquakes, they were 5+ magnitude. So it is a very risky situation. So we should not take it lightly. But because we don't know, there may be indication like 15th August 1950 earthquake. Around 20 days before, there were many earthquakes were coming. But the people were not serious. They were thinking, some people started gossiping that it is releasing of energy. Some people started saying something which is irrelevant. And when the major earthquake came, then all they said that we were saying, but why the government was not listening to the actual voice, actual science behind it. So that's what it should be taken seriously if any indication is there. That's why even in the Kutch, we were caught unprepared. So we should not be caught there. That's what is the focus. That see, the scientific studies will go on, the building construction will go on, but it doesn't mean that you stop thinking of disaster management plan, or you stop thinking of activities which are able to have or to reduce or to have the low resilience, or to vulnerability also. You should know all those things should go parallelly.
Is there any pattern of recurrence of earthquakes? Because my attention was drawn to a figure that every 30 years there was a major earthquake in Gujarat.
Yeah, this is again very, very important question, because I said that lot of energy needs to be accumulated. So for accumulation of such energy, there has to be some time, not over 10 days, 20 days, that much huge amount of energy. The energy to break 1,500-kilometer long area, or the slip of around 1 meter or 5 meters or 10 meters, it is a big amount of energy. You know that if I have to lift this mobile also, it requires some energy. So you can think of 1,500 kilometers. So it takes some time to build up. Now there have been, if for major earthquake, they say that there is a period of 100 to 500 years to build up. But as such, till date, we don't know. We call it, that's what I showed a map, that's what is a seismic gap. So we may guess, because our say 1,000 year back, which earthquake came, we don't have data. Only we can guess that by this thing, there are chances of earthquake. So until unless, say now today, if any earthquake comes, after 500 years again it comes, because today's data are preserved somehow, then we may say that it takes this much time for this much big earthquake, if the similar earthquake comes. And second important thing before we move to another question, the earthquakes keeps on occurring at the same place, same area, where, like I told you, the Indian plate is moving. So Indian plate will not start moving towards the other side. Indian plate is moving towards the Eurasian plate. So we know that where are the places where the stresses are generating. There only the earthquakes. This is not for 100, 500 years. This is for 50 million years ago onwards. I told you the data. So from that time, it is moving in this direction. So that's what is important.
Thank you very much, Dr. Valge. Now, may I invite Dr. Santosh Kumar, he is the former director of National Institute of Disaster Management, New Delhi. To please make his presentation. His presentation is going to be the most important from our life point of view of our lives.
3 minutes time or 4 minutes?
It's up to you, sir. You can take 5-10 minutes. 10 minutes actually we had kept. So
No, it was planned for up to 4 o'clock, so I thought I must ask you.
Sure.
Okay, thank you very much to all the for the invitation. First of all, I would like to thank you that you have invited me and given me this opportunity. I work with the National Institute of Disaster Management, where I was formerly director. And prior, I was working also as a director of the SARC Disaster Management Center. That was a South Asia. And I could see that the presentations went on the different aspects of earthquake, and especially the issues related to warning and whether warning possibilities there or not. So important thing is just to, I would not go into the detailing out of the earthquake. I will take you as a larger gamut of disaster management. But first of all, I would like to compliment everyone for the World Literacy Day today. And we are trying to venture out in the new areas, which is disaster management. And this is very, very kind of an important area to be discussed and to be learned about it. I would suggest, I would take 2-3 minutes in the initial that how India is vulnerable to different disasters, and that one that we are all experiencing, that is pandemic. And that pandemic, probably when we get affected, and probably we start appreciating about disasters. So if you see this, this is the first time happened in the after 100 years that almost every individual is affected by COVID-19 directly or indirectly, whether we are locked down in the house or you are working and going outside with the mask and this hand sanitize hand or personal hygiene and everything. So all you can say that 8 to 9 billion people of the world are affected by this disaster. So this is a global concern, and this is a globally people are handling. The second important is how India is getting affected by this particular COVID-19 that everybody knows, and that whole space is full with that information, that how much everyday people are actually getting affected and what the database. And at the same point of time, India is also getting affected by cyclone and the flood and the disaster. Like you have seen that how it happened in Bihar floods and now Assam flood. and also West Bengal, and then also Bangladesh cyclone. So interestingly, that at the point of COVID-19 also, we are also getting affected by various other disasters. The third point which I would like to mention here, that all the three presenters and the panelists highlighted about this earthquake, which is most uncertain disasters, which we say that low frequency and high impact disaster. And that is basically everybody is saying that if you know about this well in advance, then probably we can mitigate the risk. So that is this concern about this earthquake. And normally we are ignorant when we do not give that much of importance as we are giving to COVID-19. That's what I'm saying, that COVID-19, everybody is affected, so that we know the nuances of that, what disaster can create impact. Similarly, when people who are living in the flood-prone area, it is for them that's a disaster. Since we are living in Delhi or maybe some other place of the country, and we are not affected zone, then probably it's not none of our business. Probably it becomes as a kind of thing. So it is very, very pocketed areas, and Mr. Walia and Sanjay and Mr. Dr. Sanjay and also this Mr. Lindo was highlighting that various areas, especially the zone 5 and the zone 4 of earthquake, they were highlighting that northeastern area and all the hill states are much more vulnerable other than Gujarat and also Maharashtra, which was earlier not mapped as a very seismic active state, but they also got affected by disasters. Madam also referred about this Kangra earthquake. So Kangra is a Himachal, is another big story of disaster. Recently, in the recent past, we have seen Nepal earthquake in the hills. So what kind of lessons could be drawn from this earthquake, flood, cyclone? And the Japan tsunami, I would also like to refer of 2013, which is a kind of a cascading nature of disaster. So that cascading nature is making our life much more vulnerable, and it's much more challenging for how much we should know about the disaster. Like earthquake happened, that during that time the building behaved differently in Japan, but did not kill much of the people. 1 or 2 deaths happened, even if that earthquake size was quite big. Meaning thereby the vulnerability of the building in 8 point something earthquake happens, India will collapse. Because we have seen 6.9 earthquake in Bhuj, you are referring again and again. So Bhuj earthquake, you can very well imagine. So we have not been able to develop our capacity of infrastructure as that Japan has been able to do, recognizing this as a challenge. So another thing is that earthquake has also given a lot of surprises. That Latur was happened in 1992, and they did not have any signal of seismic activity, as all the seismologists that we keep saying, and we have the zonation map also drafted is a physical vulnerability map in terms of disaster. So there also the big earthquake happened. So this kind of unpredictability and uncertainty is there. Side by side, they are showing that continental drift is also taking place. I remember I was talking to one of the journalists, and he asked me over phone that what is this meaning of a big earthquake or vulnerability in India. I told him that probably there's a big earthquake, could be possibility of it, which all the scientists have made in their presentation, that India is capable of getting more than 8. And so that what is the uncertainty? Uncertainties can come tomorrow also, it might not come in 50 years also. That return cycle, we say, the 50 years of return period, 100 years of return period, 150 years of return period. This does not mean that in 50 years it will come after 100 years or 150 years. Within 50 years of time, it can occur anytime. So that is the meaning of 50 years of return time, 100 years of return. So bigger earthquake might be possibly knocking the door, because seismologists keep saying that that energy has already pent up. So that how much we are ready for that. Seeing this, that if tomorrow morning there is an earthquake, if say that this is the warning time given already, They say that we are asking question on warning and warning. I say that warning has already been given to the people of India. That seismology graph has been done, map has been done, microgenesis have been done. So these are the actions have been taken, and they have identified this area might get this possible earthquake. So this is the warning. And uncertainty is there that it's not like a cyclonic storm that you will get warning 2 days advance or 3 days in advance. So that possibility is not so far, the dent has not been made. So the criticality, the more uncertainty, the more likely impact would be. So the journalist next the time is flash the newspaper that tomorrow is a big earthquake is coming. So so that panic all over. So that we need to also appreciate and understand the uncertainty is there, but how to deal with these uncertainties. So that is this important thing which I would say. Like Dr. Walia was saying, whether the builder is aware or not, whether the builder is making or not. But individually, how much, what is my capacity? What is my elderly population, those who are living with me in the family? Suppose I have a composition, 8 persons living in the family, and we feel tremor. Say that example I'm giving. So how I would be reacting, and we have a 6-month-old baby also in the house. So whom to say, myself or to aged parents, or to 6-month-old baby, or to my wife or to myself? This is the critical questions which we need to discuss at the dining table every day. That we don't discuss, so we should start discussing that. That in case of tremor, which we feel and the time is very short, we said that 58 seconds could be more than enough. And in that 58 seconds, what could be the possible response of an individual? That is a challenge. Where if you are living at the 8th floor or 7th floor or individual house, or you are living in squatters or living in huts. So that is much more important, that how 58 seconds preparedness of individual would be there. You may be having best of the system in the world, but that will not respond and they will not come for your rescue for that 58 seconds. So that is 58 seconds are much more challenging than an hour, 2 hours, and 4 hours, and 10 hours. After that, you have a local system and management that you do that. So this is the possibility when we draw the vulnerability profile of the country. People are, the more unaware we are, the more vulnerable we are. So this is this kind of a challenges which we have. Like even if the tsunami time happened and the sea receded, we did not know that sea receded and what to do and how to respond, because that time we said that tsunamis are known to us. But now currently we have tsunami known. So how Japan done, when we said that, I was giving example of cascading. So when the earthquake happened, building responded well. People responded well. The second, then it got converted into tsunami. So how tsunami happened? Tsunami, the same if happened in the sea, earthquake and it or the big landslide, tsunami generates. So tsunami generated it. Whole city, most of the city of Sendai prefecture got inundated, and there was a big nuclear energy plant, and that also they could not do the cooling because of this water inundation and all. So it converted into nuclear emergency as well. So power cut, nuclear emergency, you have a flooding all over, and you have also earthquake. So one disaster led to 5-6 more disasters. So like in India, if you are seeing what is happening in Kerala, you are seeing huge rains. That is itself is a big thing. Then second is this, you are getting inundation, flooding, and then you are having landslides. So people are getting killed by cascading impact of disasters. So just not one earthquake will happen, it will bring many other disasters too. So like when an earthquake will happen, it might be short circuiting will take place, might be fire also, might be some industrial accidents also, might be some industrial. So just cascading. We are doing risk modeling only on one single individual events. If you are doing for flood, we are just doing for flood. Cyclone, earthquake. So that's cascading impact model we have not been able to inculcate so far. But what we are realizing, this cascading model during that's what I'm giving an example, COVID-19. Everyone is facing this pandemic. but also facing with flooding, and also facing with the cyclone, and also the landslides and other things are happening. And one individual community, like suppose we are living in that area, how I should be responding, how I will take to, if a rescue team are coming, we are questioning whether they are corona affected or not. If I am not affected, whether I will be affected in the relief camp or not, whether I will be taken safely in that area or not. So that kind of apprehension and doubts which are coming to the people's mind. So they will be reluctant to go out, and they will rather facing the disasters to come and hit them. This is also happening. So what I'm saying that people are going into different, and this itself has been a big trauma to the people, and they are traumatized. Many suicides are reported in the television. Noida itself was reported 300 and something suicide happened just during the COVID-19 period. I do not know the correctness of the figure, but I'm giving an example how this psychosocial counseling and the need is now coming as a everyday intervention by the disaster responders, and health sector should start functioning on that. Civil society should get geared up. Many individuals are there, psychosocial trauma counselors are there. They can start taking care of this. So there is a new challenges. What I'm saying is emerging now. Things you talked about 2001. What happened in 2001 is now totally different in 2020. And then we have committed ourselves internationally also by 2030, 3 major goals to be achieved. Sustainable Development Goal, COP21, and then we are also talking about risk-free the country, to a risk-free country. And all 3 we have internationally committed. So, and COVID again is there, which is showing a sign of another challenges of economic depression. So it's a worldwide. So now how the global community can come together, this is what point I would like to refer. Like at the time of COVID, when we are having cascading disaster, I say personally that unless and until we will be able to attack COVID-19 properly, we will not be able to fix up the economy also, and we will not be able to fix up the trauma and disaster also. And it's a global concern that started in Wuhan city and in Wuhan, and it spread out to all across the globe. So even if is living in one mohalla of any part of the country, it has the potential to damage across the globe. So what I'm saying, taking the analogy from Wuhan, and if it gets left out in some of the cities or in the villages, it will have the capacity to destroy the whole world again by the pandemic. So the idea is to how global community can come together and start thinking of, which they have come already. They're working on vaccines and everything. It's a good model. Similarly, some regional cooperation could be brought in, local capacity to be built. But the idea is coming on the individuals. That is the much more important. How individuals are getting prepared. Every family is getting prepared. We are talking in webinar. It will remain with us. It will go as a kind of a memory of maybe how many people are attending. I do not know. But it should not get confined to those number of people alone. It should spread out. It is a challenge, and it should go to every individual's house. So that effort we need to make, maybe with the institutions, with the organizations, corporate sectors, media, social media, print media. Idea is that what I'm saying is that we have to have a positive story always in front of us, and these are the challenges will be there as all as other natural activities. We should not add to the problem. That these are the activities bound to happen, natural activities, all the 3 panelists said. But if we start constructing bad houses, bad infrastructure, then we are adding to the problem. If we are not adhering to the norms, I say that in COVID-19, if you are going out without mask and not sanitizing yourself, if you are going into the crowd and not wearing mask, it is affecting us and also affecting the community, vice versa. So that kind of a culture of prevention has to be brought in the larger gamut of disaster management, just not confined to the pandemic alone. But idea is to look for all the disaster. Is also what I'm saying, pinching the wallet. And every time we are saying that India is losing 2% of the GDP on different natural disasters. So that kind of a challenges, but individually we need to prepare. And how that will go to every household, that we need to think, and we all players have to come together and take that. And it should be a part of the dining table discussion of the family. Thank you very much.
Thank you, Dr. Santosh Kumar. As you rightly pointed out, one, the role of the people, and second, the interrelated interrelationship between one disaster and the other. Like during the COVID times also, because of cyclone Amphan, I was told that this COVID cases increased many-fold in West Bengal, maybe 2 or 3 times. So this is one thing. So education of people is very important, and I have seen that the community, the more they have got involved into rescue operations, they could do it faster. So what is the role of NIDM in training the community leaders? Being in IFUNA here, Indian Federation of United Nations Association, if we want to get associated with you, what type of training do you impart to the volunteer?
We have a multi-fold kind of a role which we are doing at the time of COVID, and before that also what we were doing. Largely for community engagement, we are doing one that as an educational institution, education and training research institution, we have made different modules for the communities. We have a village disaster management plan. We have a district disaster plan. We have a state disaster plan. And disseminating this plan, it is being developed by the people themselves. So we draft module and all, but we work with the community and develop their own plan. So they understand their own risk. So that is one way of doing it, that we go to the community, our people go to the community, our state government people go to the community. So cascading model we have here also. Like we have trained the trainers, then the trainers are training other community leaders, and then community leaders are taking them to there. The second is that we found, and especially I advocate for that, there I found for educating community and informing community, I found our firm belief that women are the best leaders for taking such kind of engagement. Their leadership, their wisdom, they understand risk better than us, I would say, and they are the better risk managers. I've seen a different forum, nationally, internationally also. The way the challenges they handle. In India also, I'll give you one example, the community, which you said that NIDM is doing. So on the basis of that, NIDM have drafted many modules. Whether you talk about centuries ago or you talked about this century also. I remember the Rajasthan happened in this, it's a very famous kind of a Chipko movement. We call the first Chipko movement of Khejdi movement, it is called. So there the king was making villas, no? And they ordered the Sipahi to go and get the forest wood for the construction of the villa. So they all went to the village, and this is the story of Jodhpur, especially this Vishnoi community. So what happened when they went there and they started cutting the forest? One woman came outside the house and they objected this. Okay, this is not done, and then she was killed by the Sipahis because he wanted to please the king, and women was the kind of they took this initiative to stop. When it did not stop, then her 3 daughters also came for this. All 3 were also killed. Then other women came for the village. I was just wondering, and when I was reading this entire story, that whole village was composition of men and women, and why men were not coming forward and sacrificing their lives, but why women came forward, because there only one argument they worked on, that this is for the survival of the community, so that forest should not be cut, and that was the major force they took forward for the larger interest of the community. They were not thinking of their forest is getting cut. So then when the king got to know, and then he suspended the whole cutting of the trees initiative. So, and then you see what happened in Uttarakhand. Then women took initiatives, and the whole Chipko movement went on. And this the second is sole risk assessment. What I'm saying, that knew that what is the risk for the future. They knew that much of the landslide will take. It started after the Alaknanda flood, 1972, and see that they have changed the entire ecosystem of that area. So that is another story, and many more stories from in Africa, Guatemala, and Latin America also. Wherever I've seen that, especially risk management, especially in coming to the disaster risk, they have championed themselves. So that community, we started working with the community leadership. That it's more of a kind of a bring the women's group also in the forefront. Not only men, but the women groups also in the forefront. And Maharashtra is doing excellent work in all. This Swayam Shiksha Prayog is doing good job on that. So many such examples. Secondly, we have started also leadership training and informing people in the parliament. Parliamentarian, we have developed module for the parliamentarian. We are interacting with them. So that is another top level leadership. And then middle level, and then we are talking, we have an IDM has done for the legislatures also in the state. So that leadership one way, then executives, functional. So executives also we have taken, and now judiciary. So we are talking to the, we did one workshop for the judicial people also. Then comes to the media, and then we develop module for the media person, how disasters should be reported, how should be done, and how the mitigation measures can be brought in. Many media people are coming and they're getting, we have a module. If you see our website, you can find those things are there. So this is the humble beginning which an IDM has taken place in terms of capacity building. Other than that, we have also engaged in masons training, because Gujarat we found in the recovery, it was the biggest challenge that how to have 11 lakhs, how to be reconstruct. We did not have much of engineers and masons trained on earthquake resilient housing. So large number of masons were trained during that time. Large number of engineers were hired and they were trained. So that learning was brought in the mainstreaming training program of an IDM. So masons training, then also that engineers training, and Dr. Wali and all panelists, they are also involved with us. We are getting all this where the disaster happened. Administrators, those who have handled disasters, they can share. They are sharing their experiences in our platforms, how they have handled, like say whether I talk about Kerala, talk about tsunami, or talk about Himachal, even or talk about international experience of any other disaster. So we are bringing national and international and the local land knowledge together, and we are sharing in the form of training, education program, and during the COVID, we are doing large number of webinars. Every time you see, and there would be announcement of webinars, and 400, 500 people are attending that. So this is blessings in disguise. What we say that the model of entire training and information education system has changed. The only worry which we find today in the COVID-19 is that it's getting a great digital divide. Those people are at risk. They are not accessing our thing. They do not have much of technology friendly. They do not have much access to the this you can say laptop or mobile phones or Android phones and all. Those who are living in the coastal line area, probably they might be having, might not be having, because we say that 34% people are still, so 38 crores of people are still below poverty line in India. So how, and people are at margin. How we can access them? Similarly, we have a child-centric disaster risk management, especially focusing on the children-related issues during the disaster. COVID-19 has given many challenges to the children. So our CCDRR center is focusing entirely on the children-related issues, their trauma, opening of a school, non-opening of a school, their evaluation pattern, and so on and so forth. So how to open, how a school can get ready if they have to open it. Just opening is not a fun, but you have a total preparedness for opening and getting children. And if we are opening these schools and children start getting affected, then it will be a chaos in a different situation it will go. So that kind of a challenges we have taken and we are trying to do.
Thank you very much, sir. And the floor is open to questions. If you have any question, you may ask. And after that, I invite Professor Ashan Reddy, our secretary, and President of UNA Arunachal Pradesh to propose a vote of thanks. Any question? One by one. So there are no questions, I believe. Professor Reddy?
I have one question. If you have to say another question, I have to say something. Can you kindly permit me, Deepak?
Sure, sir.
Deepak?
Please go ahead. Yeah.
Deepak?
Yes, sir. Please go ahead.
Thank you very much. First of all, I would like to congratulate Dr. Sanjay, Dr. Lingdong, Professor Devesh, and and Professor Santosh Kumar for enlightening us. We really feel very much enlightened by today's webinar. And I would like to tell this honorable guest that our UN associations are having presence in more than 100 countries. And our editor-chief, Mr. P.M. Parvati, is also sitting here. We will be publishing about this webinar, and then we will be sending to about more than 100 countries about this webinar. So thank you very much and for enlightening us. But I have one very small question, which I, as a very layman, I would like to ask you, or I like to tell you. When I was very young in the year 1967, there was an earthquake in Koina. And after, so many lives were lost. So many people lost their lives. So many properties were perished. And then we started hearing news, getting news in the papers that the animals were having premonition, that they were knowing a knowledge that the earthquake is coming. There was a story that the horse were thumping the earth for the whole night. The dogs were have put their ear on the earth and they were barking. The birds were chirping in a different manner. Does these stories have any substance about, or is there any research on this subject that the animals or the birds, they have some understanding about the coming event of the earthquake like that? That's only my question, which is of course a question of very layman, but since I have read in my young age about these stories, so I would like to, so all the experts are sitting here, so I would like to know, so that we are also able to tell the whole world that these stories are, I mean, proper, not good, or are just a story and no substance in that. So please, on that as well, I'd like to ask only this very simple question. Thank you.
Hello.
Yeah, anyone can answer this. Anyone who wants to answer this? Dr. Sanjay?
Yeah, regarding this, I want to say one thing that as far as like for example, since I am more concerned with weather forecasting, you know that nowadays we have increased our weather forecast, the accuracy of weather forecast to many folds. Our forecasts are now going even up to about 90% correct. So it means that we are now able to understand the atmospheric system, but still there are some things which are still lagging, due to which sometimes our weather forecast misfires. But at the same time, you must be knowing that even uh, the starting of this human civilization, and when people started to understand, to observe and understand the weather system, many this Kalidas and especially this Ghag Bhattari, he has many, उनके बहुत सारे दोहे रहे हैं जिससे हम लोग को पता चलता है कि वो वेदर फोरकास्ट, जैसे चींटियां अंडे लेकर के आ रही हैं, तमाम इस तरह की चीजें हुआ करती थी। तो सिमिलरली ऐसा जानवरों के साथ भी कुछ तो जरूर है। द थिंग इज दैट कि हम उसको कितना स्टडी कर रहे हैं और क्या हम किस निष्कर्ष पर पहुंचते हैं। Definitely all over the world, people are working on this to predict this earthquakes. I'm not sure about Indian context where and who are working on this particular thing, लेकिन आपकी बात से मैं बिल्कुल सहमत हूँ। And of course I think that definitely इस पर भी कहीं ना कहीं रिसर्च हो रहा होगा।
Maybe Dr. Walia can throw some more light, being a scientist. Dr. Valya, would you like to say something on this? Is he there? If there is some problem there. Dr. Professor Edie, can you please propose the vote? Any other question anybody has? Thank you very much. Yeah, I hand over the mic to
Yes,
Professor.
sir. Yes, Parvati sir, am I audible?
Yes, sir. Yeah, thank you. Please go ahead.
Okay, okay. Good evening to everyone, and I'm very thankful to Sri Suresh Srivastava, who is the Secretary General of Indian Federation of the United Nations Association, for giving me this opportunity to propose the vote of thanks. And I also thank him, Sureshji, for organizing such a very, very important and relevant webinar, and on this day of this International Literacy Day. In fact, it's very important and very relevant, particularly in the context of people who are living in these this 5 zones of this earthquake. I also, on behalf of the IFUNA, extend my thankfulness to all the experts, Dr. Sanjay Savai, Director General, Deputy Director General of Indian Meteorological Department, Guwahati, Dr. S. Lindo, Director in Charge, cum Scientist, National Center for Seismology, IMD, Shillong. I also thank to Professor Devesh Walia, Professor in History, Department of Environment Science, Northeastern Hill University, Shillong, and Dr. Santosh Kumar, former Director, National Institute of Disaster Management, New Delhi. I thank you all of you, and you have made it, your point very clear, and you have handled this, the issues very clearly, lucidly, and very scholarly and very in-depth. And we are very benefited from you, and we are very enlightened and feeling more comfortable in case if any earthquake happen. And I think I'll follow the step what you have been talking about that. It's very helpful to us. I also thanks to our very respected and efficient moderator, Deepak Parivartaji. So you have handled this session very effectively, very nicely, and I think we need to learn from you how to moderate this kind of webinar. And you are also program director and media advisor of the IFUNA New Delhi, and we belong to same family. Thank you, Pratibhalji. And also thanks to all the participants who have actively participated. And especially I thankful to the one madam from this Himachal Pradesh. She has been participating very actively, and your participation itself is the encouragement to the IFUNA. And I think
Madam
in future, if you organize such a similar kind of webinar, I think I can expect a similar kind of participation from you all. Finally, thanks to every one of you. Sureshji, thankful to you for giving me this opportunity. I'm very pleasure. I'm very thankful. I'm very blessed. Thank you. Thank you.
Thank you very much, sir.